Hi guys, in this episode of Shri series, we're going to be talking about right angle trigonometry, and I'm going to give you a basic theoretical understanding on what we need to know when solving questions involving right angle trigonometry. And in my next set of videos, we're going to be applying those questions. All right. Now, if you've looked at my previous video on Pythagorean theorem, we refer to as a right angle triangle. So I'm just going to sketch a simple diagram of a right angle triangle. All right. So in a nutshell, a right angle triangle is a triangle where one of its angle is 90 degrees or is a right angle. All right. So that is 90 degrees. And the symbol for a right angle is this square here. Okay. So whenever you see any triangle with the square symbol there, that tells you it's a right angle triangle. All right. If you don't see that symbol, please don't assume that it's a right angle triangle by saying, oh, even if that symbol's not there, as long as it looks like it's meeting at 90 degrees. So please don't make that mistake. Always remember, a right angle triangle will have that symbol there. All right. Now, before we go any further, we need to look at key certain points that we learned from Pythag. Now, if you remember using Pythag or Pythagoras theorem, we used the famous formula c squared is equal to a squared plus b squared, and we refer to the longest side of a right angle triangle as your hypotenuse, or the short term was hyp or h. All right, so we're going to be using that information and add two more words or two more lengths or two more sides in a right angle triangle, namely the opposite and the adjacent. So I want you to understand this bit, and we're going to be using this in your right angle triangle. All right, so I just wanted to briefly tell you what Pythag is, because we're going to be using this information. What's common between Pythag and right angle trigonometry is the word itself. We are using right angle triangles. All right, so we've established that this is a right angle triangle. I'm just going to continue that point here. All right, so by now we can identify that is my hypotenuse. All right, so what I'll do is I'll put a key there. So H stands for hypotenuse. All right, now let's look at an angle. All right, suppose we have this angle here and we'll call it theta. All right, now theta is a Greek word or Greek letter, that we use to denote angles. It's very commonly seen in textbooks as well. As we know very well, the Greek mathematicians came up with a lot of theories involving trigonometry and Pythag. All right, so that's what we call theta. So assume we have an angle called theta. What we want to do is we need to identify these two side lengths. So we've got this one here and we got this one here. It's pretty straightforward, because if you look at it carefully, this bit here is opposite. All right, why is it opposite? Because that length is literally opposite to that angle. All right, so if I just put an arrow there, that will tell you that that length is opposite to that angle. All right, so let's call that as O. All right, and the symbol for O in this case is opposite. All right, so we've identified your hypotenuse, which is the longest side of a right angle triangle. We've identified your opposite because it's opposite to the angle. And the next one here to identify is this side. And this is A, and A means adjacent. All right, now you hear people saying in common language, could you sit adjacent, or these two are placed adjacent, which means it's placed closer to that angle. All right, so A stands for adjacent. So you got to remember, in right angle trigonometry, you need to identify the three lengths: your hypotenuse, your opposite, and your adjacent. All right. Why do you call it opposite? It's because it's opposite the angle in question. And why is it called adjacent? Because it's adjacent to the angle in question. The good news is when you change your angle, your hypotenuse remains the same. What only changes is your opposite and your adjacent. All right, so just remember that. Okay, so your hypotenuse does not change at all. All right, it's only your opposite and adjacent that will change. Now, we've identified the three sides of a right angle triangle. And just remember, trigonometry is not just about calculating the length, but it's also about calculating your angle, finding the value of your angles. So this is why it's very important to understand what we refer to as trigonometric ratios. I'll just write it right here. Trigonometric ratios. All right, or trig ratios. All right, so what do we refer to as trigonometric ratios? These trigonometric ratios will help you find the angle in question. All right, and we have a simplified formula that we use. This will help you to solve these questions, and I'll write it down here. So SOHCAHTOA. All right, what do we mean by that? All right, SOHCAHTOA. Now you can see O is opposite, H is hypotenuse, A is adjacent. All right, so let me explain what we mean by SOHCAHTOA. Now this is technically the trigonometric ratio that we use to solve right angle trigonometry. I would even go as far as saying that's your Bible. That's what you need to remember, SOHCAHTOA. And I'm going to break this down and explain to you what we mean by that. All right, so I'll start with So S means sine. Now, let's think of a situation where we need to find the angle. All right, we need to find the angle in question. We've been given opposite, adjacent, hypotenuse. How do we work that out? All right, so the formula here is sine theta is opposite over hypotenuse. So when you get the length of your opposite and your hypotenuse, that ratio will give you sine theta. Now let's look at CA. So I'm just putting this arrow here just to show you what that links to. Now let's look at CA. CA basically means cos. So in other words, the C is cos, and that's adjacent over hypotenuse. And the last one is TOA, where the T stands for tangent. All right, so we call that tan theta is opposite over adjacent. This is a trigonometric ratio that you're going to be using to solve and find angles using your lengths. All right, and like I said before, in the next couple of videos, we're going to be practicing these questions. This video was just to give you a theoretical understanding and the formulaic ratios that you need to use to solve right angle trigonometric questions. All right, so the key is SOHCAHTOA. This is used to find your angles, or should I say the trigonometric ratios. All right, you need to know what O, A, and H stand for, which is right here. O is opposite, A is adjacent, H is hypotenuse, and S stands for sine, C stands for cos, and T stands for tangent. All right, so sine theta is opposite over hypotenuse, cos theta is adjacent over hypotenuse, and tan theta is opposite over adjacent. In my next set of videos, we're going to be applying questions that involve SOHCAHTOA. Thanks guys for listening. Bye now.